Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back to SIC1004. Today we are going to proceed to experiment 2, which is on the pH measurement. So the objective of this experiment is actually to measure the ionization constant of various acids, and I will highly recommend that before you actually continue with the slides, please watch this video which explains on how this experiment is conducted. So this is really a very short experiment, and that's why we do 2 experiments on the same day, experiment 2 and 3. So with regard to this experiment, so this is pretty much should be familiar to you. You know that the strength of acids can be compared by the value of the dissociation constant. So for strong acid, you have a 100% dissociation, and there's almost no undissociated molecules. So examples of these strong acids: hydrochloric acid, sulfuric acid, and nitric acid. On the other hand, the weak acids will only partially dissociate in aqueous solution. And so with regard to its ionization reaction, so you have this equation, and the ionization constant can be calculated via the products over the end materials over the starting materials. And because the concentration of water is pretty much constant, so it's not there. So we would sometimes evaluate or gauge the strength of the acid by the value of pKa. So as soon as you have the P here, it just means that you have the negative log of that. And so what you will be doing is actually measuring the pH and then eventually the pKa, and from there you can measure the value of Ka. So mathematically, I do hope that you know how to convert in getting the pKa to get the value of Ka. Okay, so this is something that you have to figure out, and I hope that you know how to do it. Okay, so you have this in terms of the materials. You have the buffer solutions, and this is important to actually calibrate the pH meter because you want to avoid the systematic error. Phenolphthalein is used as the indicator, so obviously there's a titration involved here, and you use 0.1 molar of various acids, namely the acetic acid, propanoic acid, chloroacetic acid, dichloroacetic acid, trichloroacetic acid, and the base will be sodium hydroxide. So first, you need to prepare 15% neutralized acid, and you do that by first adding 25 ml of this acid. You start with 1 acid and in a conical flask, and you add the phenolphthalein, and you start titrating with the 0.1 molar of the base sodium hydroxide. Okay, as soon as you have reached the end point, so you will add another 25 ml into that of the acid into that same solution. So that's considered neutralized. So that's something that you have to explain. Why is that so? Now, as I said prior to that, you need to calibrate the pH meter to ensure that the pH meter is working well. And so what you need to do is then measure the pH of that 50% neutralized acid, and record the temperature, because the pH will depend on the temperature. And so then you just keep repeating the process. Now, in terms of doing the experiment, because there's a tendency to overshoot during your first titration, so students will usually do it 3 times and then take the average of usually the second and the third. So unless you do it carefully the first time and you don't overshoot, then you can actually take the second time, so you only do 2 titration. Okay, so very experimentally it's very easy to conduct this. So what you get, as you can see in this data sheet, you have the pH readings, and you use the thermometer, although that's the thermometer on the pH meter, so it's not accurate, so you use this take a separate mercury thermometer to actually measure this the temperature of the solution. Okay, now what you need to do is to actually prove that pH is equals to pKa for 50% neutralized acid. So please prove this equation. So as you prove this, you will also you either prove it, you can prove this in the theoretical background section where you have the objective and you talk about theoretical background. So please do this as part of your theoretical background. Okay, so once you get that, since pH is equals to pKa, then you can easily convert the pKa to get the value of Ka. So I would like you to actually evaluate, change the value of Ka in terms of multiply it by 10 to the minus 5, so you can easily see the trend here. Okay, so you can definitely from this, you know that there's a trend involved here. So what you need to do is comment on the changes in the Ka values. As you substitute the hydrogen with chlorine, explain what's going on and how does that actually affect the Ka values. So that's very straightforward. So prove this and get these values, and also report on the trend. Okay, and so these are the values that from the data of a student. So all you need to do is just take the average. So you can see here from this this in which the students actually take the second and the third titration only, so you take the average of this, and so with that please report on the what you call the report on the trend. Okay, convert it to Ka and report on the trend. Okay, so this you need to, as usual, the report will consist of the title, name, your metric number, and please put your picture again so that I can recognize you when I see you face to face. The objective, that's already stated. Theoretical background on this, and especially on the 50% neutralization, and prove the equation in which pH is equals to pKa. Results and discussion, so you will discuss on the trend that you will see, and conclusion is just reporting back what are the Ka values of these acids that use. So references in APA style. Some of you actually been doing it in numbering style, so if you do that, that's also okay, but make sure that you're consistent. Okay, and this is due next week, so you have 1 week to do that. Submit to the same email, and because you have 2 lab reports to submit, make sure that you have the 2 documents, experiment 2 and experiment 3, in one email subject. So don't make it separate email, just email them together in one, the 2 documents in one email. Okay, so that's all for this experiment. So thank you for now. All right, bye.